Protecting employees from the effects of dust explosions and fires in the die casting industry, Unit 2. After completing this section of the course, students should be able to implement work practices and procedures necessary for dust explosion and fire safety at the plant. The practices and procedures discussed in this course are adapted from NFPA 484, Standard for Combustible Metals, 2006 edition. Some of the practices and procedures that are of greatest concern are appropriate housekeeping, fugitive dust control, and safe handling of fine particles. Key facts you should know. This section presents some key information regarding combustible metal and dust operations, the metals used in the die casting industry. Some of this information is unusual and not widely known. Health and safety depends on the recognition of actual or potential hazards of combustible metals, particularly metal dusts, the control or removal of these hazards, and training of employees on safe working procedures. Important guidance on health and safety is found in NFPA 484, Standard for Combustible Metals. Everyone working with combustible die casting materials, particularly in the form of dusts and fines, need to know some key facts. Emergency response and preparedness are specifically important. Containers for molten metal must be cleaned and dried prior to receiving the molten material. Metal pieces charged into liquid molten metal must be clean and dry. Water-wet containers and charged pieces can cause a molten metal explosion. When combustible metals burn, an intense, extremely hot, orange or orange and white flame is produced. This is accompanied by a large volume of white and gray smoke. If the burning metal has been contaminated with water, the fire will be more intense. Water does not mix with burning combustible metals. The intensity of the burning will break the water into hydrogen and oxygen and greatly increase the heat and energy being released by the fire. Explosions have been produced by applying water to burning combustible metal. Carbon dioxide has a similar effect in that it breaks down into carbon and oxygen. Most combustible metals will burn at 100% carbon dioxide. Halon type or other halogenated extinguishing agents may decompose into hazardous products and are not suitable for use on die casting metal fires. Dry chemical extinguishers may be used on burning flammable or combustible liquids that are mixed with combustible metal if the metal has not yet started to burn. Dusts, fines, and powders produced from die casting metals may cause explosions. If these materials are in a confined space, the concentration of particles may be higher and more likely to explode. Chips and turnings few ignite with a very hot flame. If they are coated with cutting oil or other petroleum product, there may be a tendency to ignite spontaneously. Heavy wall die castings, thick bars, and ingots are difficult to ignite or may not ignite at all. If ordinary combustibles are burning and heat up these heavy materials, especially magnesium alloys, the heavy items may participate in the fire in a spectacular fashion. Burning combustible metals produce an unusual amount of heat. Such a fire may cause water to come out of concrete or even rocks. This water may cause increased burning, burst the materials, and cause pieces of rock or concrete to be thrown about. Asphalt paving material can be involved in the fire because of the intense heat given off. Fires in die casting metals cannot be directly extinguished. They may be controlled and separated from the oxygen in air, cease burning, and cool. In die casting metal fires, this is done by applying dry extinguishing agents to completely cover the burning materials. Combustible metal dusts and fines create unique hazards. If they contain or are contacted by moisture, they can produce hydrogen, a flammable gas, oxygen, an oxidizer, and heat. This can cause an explosion or fire. Magnesium, aluminum, or a similar light metal or alloy dust, not oxidized, can react in contact with rusty iron and produce heat in what is called a thermite reaction. Specially made tools are used to avoid this and friction sparking. Thermite reactions can be an ignition source. Thermite sparking was identified as a hazard in coal mines in the 1940s when articles made from light alloys accidentally hit or dropped on steel structures or machinery. Magnesium or iron powdered mixtures have been used to demonstrate this reaction in chemistry labs, a spectacular show. Storage areas for containers of combustible metal are to be equipped with material handling equipment that would enable a container to be removed from the area quickly and efficiently in an emergency. Stored die casting metal dusts, chips, and particles that contain moisture can produce hydrogen gas. A significant amount of hydrogen produced in the storage area can produce a Class 1 Group B hazard location. Ignition sources must be excluded and good ventilation provided. This section presented some key information regarding combustible metal and dust operations. The materials used in the die casting industry. Some of this information is unusual and not widely known. Please complete this practice quiz before you move on.